Alright, for this second video for 5.5, we're still going to be using double angles, but now we're going to use it when we solve equations. We solved equations before in section 5.3 when you want to get the angle measures. And this we're just going to do one revolution, so we don't have to add the plus 2 pi k. What's going to stand out for both of these examples, and we're just going to do both of these examples for solving equations, is now we have a double angle. We have sine of 2x and cosine of 2x. Now we've never seen this where this is just x and this is 2x. There's really no way to do this. You want to get everything in the equation where this right here is just x. So this is where I'm still going to put 2 cosine of x. I'm still going to bring that down. I'm going to substitute the double angle formula. Now the double angle formula, which will be given to you for sine of 2x, is 2 sine of x times cosine of x. And then we have that equals 0. So this is what I substituted in for sine of 2x. Just like that, I get rid of this 2x and I have x and another x. Then from this point, we really should know how to solve this. This was just like the last quiz. One of the main techniques we used in solving was factoring, especially when it's already set equal to 0. Well, what's common? Each term has a 2, right? And each term has a cosine. So the common factor is 2 cosine of x. I pull that out on the outside, so on the inside we get 1 plus sine of x equals 0. And then this right here, well, now we set each factor equal to 0, so if 2 cosine of x equals 0, well, that's the same as just saying cosine of x equals 0. Let's get these values. Cosine is 0 where the x is 0 in the unit circle, which is pi over 2 and 3 pi over 2. Okay, the next factor, if 1 plus sine of x equals 0, well then that implies that sine of x equals negative 1. Here you only get one angle measure. The y value in the unit circle is at negative 1 and here at 3 pi over 2. So we just wind up getting these answers, pi over 2 and 3 pi over 2. Okay, let's move on to the second one. Now, as I already have underlined for number 2, is we have that double angle, but now it's for cosine. So let's do the same thing. Let's plug in the formula for this. Now there's kind of alternate forms for this, but either way we're still going to get, it'll take us an extra step, but let's use what's given to us. I know we went over alternate forms of cosine of 2x in class, but the main formula that's given for cosine of 2x is cosine squared of x minus sine squared of x. Alright, that's what we replace it with. Then I'm going to bring this plus sine of x down, so it's plus sine of x equals 0. Now you might be thinking, alright, that didn't help us out because now we still have 2 trig functions. But in order to get it in one trig function, since I have this sine right here, I could take this cosine squared, use a Pythagorean identity. I want to put everything in terms of sine, so I can replace this with 1 minus sine squared of x. Good old Pythagorean identities. Then I'm going to bring everything else down. This minus sine squared of x, and then the plus sine of x equals 0. Just like that, I have everything in terms of sine. Now I can combine these. Minus sine squared of x minus sine squared of x gives me minus 2 sine squared of x. And then plus sine of x equals 0. Now even though I have just one trig function, I can't pull out a sine. That's not a common factor or a greatest common factor because of this 1. There's no sine of x. But what it looks like, or what we have here, is a quadratic trinomial. Now I want the sine squared written first, so I just want to reorganize this. So if I reorganize this, I have negative 2 sine squared of x plus sine of x. And I always want that constant written last. So since this is positive 1, I have plus 1 equals 0. So if you have a quadratic trinomial, I'm going to factor this into 2 binomials. But before I do this, I don't like that negative there. So we could pull out a negative and change the sign of all 3 terms. So this becomes positive 2 sine squared of x. The plus sine of x changes to minus sine of x, and the plus 1 changes to minus 1. Now I'm good to go. I'm going to factor these into 2 binomials. I know if this 2 sine squared of x, well, the first term of one binomial has to be 2 sine of x. The first term of the other has to be sine of x. And then I know if this is just 1, well, I have to have 1 in each. But I only have to figure out, wait, where do I put the plus, where do I put the minus? And it looks like it's going to work here if this is minus and this is plus. Yeah, that one works. And then once we have this, I set each factor equal to 0, and then I solve for it. So this just takes a little bit longer. For this, if 2 sine of x plus 1 equals 0, then sine of x, when we isolate that, it's negative 1/2. For this one, if sine of x minus 1 equals 0, well, that implies sine of x has to equal 1. So when I get these angle measures, sine is negative, since it's negative in the third and fourth quadrant, and its reference angle is the pi over 6's. So this is 7 pi over 6 and 11 pi over 6. And then this one right here, there's only one angle. Sine is equal to 1 just at pi over 2. So these are the three angle measures. But the main thing is, somewhere in these equations that we're working with in this section, somewhere in there, you're going to have a 2x. So use the formula that's given, plug that in, and then from there use the same techniques that we used before in section 5.3.